All right, let's continue. So, number 7, what additional pair of parts is needed to prove that triangle DEF is congruent to triangle GEF by angle side if we're given that angle DEF is congruent to angle GEF? Okay, so kind of a similar situation to number 6 here, but this time they told us which test they want us to prove. So over here we have 3 cases. We could either prove these two triangles to be congruent by side, angle, or angle side. But over here they tell us, okay, I just want you to prove it by one of them. So looking at our figure, we are given that these two angles are congruent, and they've already marked those angles for us. Okay, angles DEF and GEF, we've already know those to be congruent because they told that to us. So now when you look, is there anything else that we can imply? Well, as you can see, they have this side right here, EF. Okay, if I was to pull these two triangles apart, there would be an EF with the left triangle and an EF with the right triangle. So because they both share that side EF, EF is going to be known as a reflexive side. And what that means for us is that that is going to be a set of congruent sides. So we have one set of congruent angles, one set of congruent sides. For us to have angle side congruency, I need one more set of angles. But not only that, I need to have the correct set of angles, because one set of angles will give me angle side, and one set of angles will give me angle side angle. So for me to have angle side, what I'm looking for is I need to have another set of angles that isn't going to be on the same line as this congruent side. So the only pair that I can do is right here. Okay, because these two angles are the two angles that are not going to be included on that side that we already marked as congruent. So for me to have angle side, I need to have that basically angle EDF must be congruent to angle EGF. Okay, because if I went with the other set of angles, the angles right here, that would be angle side angle, which would be another one of our congruency tests, but it's not the one that we're looking for right now. All right, so let's keep going. Let's flip the page over to number 8. All right, so number 8, which of the following cannot be used to prove the congruence of two triangles? So we have side angle side, and angle side. So keep in mind, when we talked about the congruency test, we had 5 congruency tests, okay? And 3 of them were side, side, and angle side. So those were 3 for sure. The other 2 were angle side angle, which is not here, and hypotenuse leg, which is not here. So the only one that doesn't fit is this one. A side angle, or angle side. That will not be one of our congruency tests. It just proved to be unreliable in proving two triangles to be congruent. All right, next up, number 9. If LM is congruent to LN, name 2 congruent angles. So we have sides LM and LN. Well, if we have 2 sides in a triangle that are congruent to each other, then that means that we have an isosceles triangle, which makes me think that if we have these 2 that are congruent and they want us to figure out 2 congruent angles, I'm going to think back to isosceles triangle theorem, which isosceles triangle theorem told me that congruent sides are opposite from congruent angles. So if that's the case, I need to figure out what is the angle that is across from sides L, M, and LN. But here's the thing, they're drawing a lot of extra lines in here to try to confuse us, try to make us second guess ourselves. So we need to focus in on what is the actual triangle that we are looking at, the big picture triangle. Okay, so if I've got these 2 are my sides, then that means that my last side to make the triangle had to be MN. So I'm ignoring all the other little things inside. I'm ignoring all those 3 little lines, and I'm just looking at those big angles. So in this triangle, my big angles are here, here, and here, because again, I'm ignoring any of the lines inside the triangle. So going from my congruent sides, I'm going to draw arrows to the angles that they're opposite from. So the angles that I have that are going to be congruent to each other will be angles LMN over here on the left side, and it will be congruent to angle LNM over here on the right side. Okay, again, we don't want to worry about that little Q line right there. Okay, we're just focusing in on LM and LN, and so that leads us to the big angles. All right, next up, number 10. If GH is congruent to HK, HJ is congruent to JK, the measure of angle GJK is 82 degrees. What is the measure of angle HGK? So there's a lot of information in there. So let's break it down little by marking everything as we see it in our description. So first up, GH and HK, those are congruent. HJ and JK, those are congruent. And then the measure of GJK, so this far right angle, is 82 degrees. So now we need to figure out what is the measure of angle HGK. So the one that we are looking for is over here, the far left angle. So with this one is going to involve some work for us. Okay, so we want to eventually figure out what is angle HGK, but the only thing that I'm given is I've got a lot of sides that are said to be equal to each other, and then I've got one angle to work with. Okay, so let's start breaking this thing down little by little. So what we're going to want to do, instead of looking at the big picture right here, so triangle GJK, let's break it into the two smaller triangles, and let's focus in on this triangle right here, HJK. So HJK is an isosceles triangle, okay? We know that because it's got two sides that are equal to each other. So what's more than that is that we know that with these other two angles that we don't know, since they are across from congruent sides, we know that these two angles, basically angles at K and H, they must be equal to each other because the congruent sides are going to be congruent or opposite from congruent angles. So what do we know about these other two angles then? Well, we know that we also, if we add these angles together, we're going to get, if we add these two plus 82 degrees, we can get 180. Okay, so let's start by figuring that thing out. Okay, so if I call these two angles x, okay, and I'm going to put x for both of them because I know that they're equal, then I can say that x plus 82 must equal 180. Okay, go through and combine my like terms and get the x's alone. So x plus x will give me 2x. And then if I subtract 82 from both sides, I'll get 98. So now divide by 2 and x will equal 49. So each of these angles up here are just 49 degrees. All right, so next up, I have this angle. So now let's look for this angle right here. Well, if this angle I just found out was 49 degrees, and then angle GHK, if I add those two together, I'll get 180. And I'll get 180 for them because I'm setting them to equal on a straight line, or making them a linear pair. So subtract 49 there, and angle GHK will equal 131 degrees. So now I can finally get around to solving for the angle that I want. I want angle HGK. Well, just like with the last one, if I know now that this one is 131 degrees, and these two congruent sides will be be opposite from congruent angles, then I can maybe put, instead of x, because I already used x, let's say y for these two angles. So then I can say that y plus 131 will equal 180. Okay, combine my like terms, 2y, and then take 180 and subtract 131 from 180, and I'll be left with 49, and then divide 49 by 2, and I'll get y is equal to 24.5 degrees, and that is going to be the angle that I am searching for. Okay, so for that one, we had a lot of work that we had to work through. Okay, so we had to go through and set up basically 3 separate problems. That one, they made us work for it. But in the end, we did get our correct answer of 24.5 degrees. Okay, so let's keep moving. Number 11. So we're given this figure right here. Okay, this is an isosceles triangle. We know that because of the tick marks right here. And in this isosceles triangle, they give us the measure of two angles, and we are asked to find x. So in an isosceles triangle, again, because of isosceles triangle theorem that we use back up here at numbers 9 and 10, we know that congruent sides are opposite from congruent angles. So we have these two sides are congruent to each other, and this side is across from an angle that has a measure of 2x plus 5 degrees. Well, then according to the isosceles triangle theorem, this other side will be across from another angle that also has a measure of 2x plus 5 degrees. So now we've got a triangle with 3 angle measurements, so we can add them all up and set them equal to 180. That's what triangle sum theorem tells me. So let's do that. 2x plus 5 plus 2x plus 5 plus 9x minus 12 is equal to 180. Okay, so we're just setting all of our angles up and adding them up to equal 180. So combine our like terms. 2x, 2x, 9x gives me 13x. Plus 5 minus 12 gives me overall minus 2. And that will be equal to 180. All right, get the 13x alone by adding 2. 13x will equal 182. And so now we have 13x is equal to 182. So we divide both sides by 13, and we should get that x is equal to 14. Okay, so for this one, make sure that you do include that last angle, okay? Don't just use just the 2 angles that are given to you. Make sure you get that last angle before you set it equal to 180. All right, now let's look at number 12. So number 12, we were asked to find x and ij if hk is an altitude in my triangle here. Okay, so with this, we need to recall what it means to be an altitude. What are some of the key defining features of an altitude? Okay, so one thing is that an altitude has to start at a vertex and go and hit the side opposite from the vertex. And what's more than that is when it hits that opposite side, it hits it in a perpendicular fashion. What that means is, keep in mind, perpendicular lines, they have to create right angles. So where HK intersects IJ, right angles are formed. So this angle right here, 2x plus 10, that represents one of the angles created by that altitude. So that 2x plus 10 angle is a right angle, which means we can set it equal to 90. So now from here we can go through and we can solve for x. So subtract 10, we get 2x is equal to 80. Divide by 2 and we get x is equal to 40. So that's half the puzzle. Now we need to solve for ij. So ij is going to be one of my sides in my triangle. Okay, ij is not an angle, it is a side. Okay, so ij is made up of 2 pieces, ik and kj. And we have a length for those, x plus 8 and x minus 9. Again, these are not angles, these are side lengths. So if I want to figure out what the length of ij is, then I'm going to take ik, which has a length of x plus 8, and kj, which has a length of x minus 9, and I'm going to add those two together. And since I now have a value for x, I can plug it in. So I'll get 40 plus 8 plus 40 minus 9. So we just go through and add all those up. 40 plus 8 is 48. 48 plus 40 is 88. And 88 minus 9 will give me 79. So ij, the length of ij is going to be 79.